Good morning, friends. Last we discussed about the astronomical telescope, right? Okay. And also we discussed about the different type of the telescope and we did the equation of magnification for astronomical telescope. Now, what are the problem or what are the main important points for the astronomical telescope? Here there are two important points. So questions sometime 2 marks question will be asked that day, which are two main important points for astronomical telescope. First thing, in telescope, in our also life we are using the telescope. We can see the image of an object if the light is proper. That means during the daytime we can easily observe the image of an object. This object is at far distance. Now, if during the night vision the image is not clear, so it shows that the light entering in telescope is not sufficient to form the image of an object. Therefore, the object are fainting. Therefore, the image is not clear. So here we are discussing this thing. The light gathering power and resolution, or the resolving power, are the two main important points for the astronomical telescope. Again, the light gathering power and resolving power, or the resolution, are the two main important points of the astronomical telescope. Now, what is the light gathering power of the telescope, and it depends on what? Light gathering power, that means the how much amount or the how much quantity of the light is entering in telescope. That is depends on the diameter or the area of a objective lens. Therefore, the light gathering power depends on the area of the objective. If the area of the objective is much more, therefore the light entering in the power is also more. And therefore, the light gathering power is directly proportional to the cross-sectional area of the objective. Here A is the area. Thus, the objective with the larger diameter, we can see the fainter object can be observed easily with the telescope having the large diameter of an objective. So, there is the benefit of the larger diameter of objective. Because the objective lens is much more, therefore it gives the more window to enter the light in telescope, therefore the fainter object is also observed very clearly. Now, the resolving power or the resolution. Other meaning of the resolving power is that the ability to observe the two objects distinctly. Suppose at far distance the two objects are close to each other. Actually, not very close, but close to each other. But we are observing these two objects from the far distance, so we feel that the both objects are very close. When this type of the object are observing by the telescope, at the time, how much the image of these two objects are shown by the telescope separately. This ability is known as the resolving power. So in short, the resolving power or the ability to observe the two objects distinctly which are very close depends on diameter of the objective. That means the resolving power or the ability to obtain the separate image of the two close objects, it also depends on diameter of objective. Thus, to increase the resolving power, the objective with larger diameter is desirable. Therefore, in astronomical telescope, the objective with the larger diameter is necessary to obtain the image of the fainter object or to separate the image of the two close objects. Clear this thing? So, there is the main important points for astronomical telescope. Now, what are the problems? As we are increase the diameter of the objective, there is a lens. Therefore, the weight of the objective lens with the larger diameter also increases. Second thing is that this lens is only we can hold in a telescope from its aids. Not from any point we can give the support. Therefore, the such big lenses tend to be very heavy and therefore difficult to make and support from the aids. So here, this type of the lens is very heavy. Therefore, it is difficult to make and give the support in telescope. That is the main problem. Second is that to make the such large lens, it is difficult and expensive. Also, it is very costly to prepare this type of the lens with larger diameter. In spite of the images free from any kind of aberration and the distortion. Again, the one more benefit of this type of the lens with the larger diameter is that any type of the aberration, that means the chromatic and spherical aberration are removed. And also, no distortion takes place in the image. But with the larger diameter, to prepare the objective lens, that is very difficult and also the expensive. And mounting of this objective in a telescope, that is also very difficult due to its more weight. Clear this thing? So there is the two important points. Now, next question is that what is the reflecting telescope? And what I explain the advantages and disadvantages of reflecting telescope over the refracting telescope and also give the solution. Just we discuss astronomical telescope. Astronomical telescope is also the reflecting telescope. In refracting telescope, the diameter of the objective must be required very large to increase its resolving power and light gathering power. Clear this? Okay. But what are the problem arises in refracting telescope? Due to the larger diameter of objective, its weight is increases. Therefore, the mounting of an objective in a telescope is main problem and also it is costly. To prepare this type of the large lens is very costly. So, what are the solutions of that we are discussing in this? Now, first thing, what is the reflecting telescope? The telescope in which the mirror is used as a objective instead of lens. The telescope with mirror as objective in place of a lens is known as reflecting telescope. Why the mirror used? So here the problem in making of lens of the high resolution and larger magnification. In modern telescope, the usage of a concave mirror as an objective than lens. So in short, the problem in making of a lens with the high resolution and larger magnification. Here, to increase the magnification and also the resolution, the diameter of the lens is required very large. But here the problem arises, and due to that reason, in modern telescope, the concave mirror is used as an objective instead of a convex lens. Clear this? Now, what is the advantages of the mirror instead of a lens? Okay. Now, yes, we are using the mirror instead of a lens. The chromatic aberration in mirror is removed. There is no chromatic aberration. What is the chromatic aberration? Chromatic aberration, that means as we increase the diameter of a lens. So what's happened after the certain value of increase in diameter, as we are obtaining the image is shown colorful at the edges. Not entire image is colorful, but at the edge of the image is not clear. That is made up of the different color. So that is known as the chromatic aberration. And now what is the spherical aberration? Spherical aberration, that means the edges of the image are not clean, not sharp. There is bending, not clear. So that is known as the spherical aberration. Now, second is, if the parabolic reflecting surface is used as a reflector or the mirror, the spherical aberration is also removed. Now, instead of the lens, as we are using the mirror, the chromatic aberration is already removed. Now, instead of the plane reflecting surface, we are using the parabolic reflecting surface like as a concave mirror. So, spherical aberration is also removed. One more thing, third advantage is that the mirror or the weight of the mirror is much less than the lens. Again, the weight of mirror is much less than the lens of equivalent optical polarity and can be supported over its backside. So in the lens, objective lens with larger diameter, so weight is more, therefore to mounting this lens here, the problem arises. Because in lens we can only mounting from its edge. But in mirror we can also mounting from the back side, or the support is also given to the back side of a mirror. So there is the third advantage. One is the chromatic aberration is removed due to the parabolic reflecting surface. The spherical aberration is also removed, and the mirror is much less in weight compared to the lens. Therefore, the mounting or the support problem is also removed. Now, what is the disadvantages? Disadvantages is that the object mirror focuses the light inside the tube. We discussed in detail in Cassegrain telescope. Because in Cassegrain telescope there is the reflecting telescope, and we are using the concave mirror as a primary mirror. So parallel rays coming from the far object are reflected by the mirror and focus at the principal focus of mirror. Okay, at that time we discussed in detail. The objective mirror focuses the light inside the tube, inside the telescope or the tube, so that the eyepiece and observer must be at that place. Must be at that place. And second is the obstructing light. Obstructing light. Is replaced the observer or the eyepiece inside or the principal focus of a mirror. So what's happened? The some part of the light is obstructed. Therefore, obstructing light. So these two are the disadvantages of the reflecting telescope. Clear this? So frequently the objective question may be asked from these two question and answer. The light gathering power of the telescope is depends on the resolving power of the telescope is depends on what? Instead, in modern telescope, what is the use? Or the instead of the lens, the blank is used. The concave mirror, the mirror are used. Why the mirror are used than the lens? Because there is the less expensive and also less weight compared to the lens, and also by using the mirror, the two type of the aberration, chromatic and spherical, are removed. So these are the advantages and disadvantages of the reflecting telescope over the refracting telescope. Clear? Okay. Now we also discuss about what is the solution of this problem. Okay. Okay, just to discuss about what are the advantages and disadvantages of reflecting telescope over the refracting telescope. Right? In reflecting telescope, the mirror are used instead of a lens. But here, what are the disadvantages here? The two disadvantages take place. Here, due to the mirror as an objective in telescope, modern telescope, the light gathering, that means the light are focused inside the telescope. And due to that reason, we have to place the eyepiece of the observer at principal focus of the objective. That is the main problem. And second is, as we place the eyepiece and the observer at principal focus of this concave mirror, what's happened? The obstructing the light. That means the some light is blocked. So what is the solution of this? The solution of the problem is that the observer sit near the focal point. We have to place the eyepiece at principal focus of the concave mirror. Yes, we are using only the single mirror. So what are the rays coming from the far object are parallel and focused at its principal focal point. Therefore, we have to place either the eyepiece of the observer at principal focus of this spherical mirror. And due to that result, what's happened? So we can obtain its clear image, but that is not possible to place the observer or the eyepiece at this point because that is inside the tube. So what is the other solution? The another solution is that to deflect the light being focused by the another mirror. So what are the rays reflected by the concave mirror? We need to place the another mirror in the path of this reflecting mirror. So what's happened? This reflecting rays incident on secondary mirror and again focused at another point. So the again reflect and focus at other point. So there is the another solution of this problem. Okay. So that is the advantages and disadvantages of the reflecting and refracting telescope. Now, after that, what is the Cassegrain telescope and Young's notes on Cassegrain telescope? There is the modern telescope. In this modern telescope, instead of the lens, here the mirrors are used. And due to that result, there is the lightweight. This type of the telescope is lightweight. So now the construction of the figure of Cassegrain telescope is shown. Here, it's shown in the figure. The rays coming from the far object are parallel, are reflected, are incident on the concave mirror or the parabolic reflecting surface. Here the concave mirror acts as a primary mirror. It acts as a primary mirror. So sometimes the objective question is asked in Cassegrain telescope. The primary mirror is blank mirror and secondary mirror is which? The primary mirror is concave and secondary is the convex mirror. It's convex mirror. Okay. The concave mirror or the primary mirror and focused at the focal point. Focused at focal point of a concave mirror. So the image of the far object is focused at this point, like this. If there is not present, so reflected ray meet at the principal axis at focal point. But here, the image obtained inside the tube or the reflecting inside the telescope, so there is the difficult to obtain its image or to set the eyepiece of the observer inside the telescope. And due to that result, we are placing the another small mirror in the path of reflecting rays. This another mirror is small in size. So the reflecting rays are incident on convex mirror, again reflected, and this reflected ray by the convex mirror passing through the small hole at pole of a primary mirror and focus at the eyepiece. So there is the construction of Cassegrain telescope. Again, it's shown in the figure. The rays from the far object are parallel. So the parallel rays are incident on a primary mirror. There is objective or there is a concave mirror. After the reflection, these rays are focused at focal point of a mirror. Focal point of a mirror. But in the path of reflecting rays, the another small convex mirror, that is the secondary mirror, is placed. So that the rays reflected by the convex lens are passing through the small hole of an objective and focused at the eyepiece. Thus, we obtain the image of the far object outside the telescope. Outside the telescope. So, thus it is the advantages of to obtain the large focal length in small telescope. Okay, now after the discussion of the Cassett Gain telescope, we discussed about the numerical of exercise 9.13. Already up to the 9.12 we completed. 9.13, a small telescope, the focal length of an objective. Focal length of an objective is given. FO is 144 centimeter and focal length of eyepiece FE is given to 6 centimeter. Find the magnifying power. What is the magnifying power of a telescope? That means the magnification we have to calculate, and second thing we have to calculate is that the distance between the objective and eyepiece. Distance between objective and eyepiece. Distance between the objective and eyepiece is the addition of the focal length of objective and focal length of eyepiece. That means the FO plus FE. Now first, magnifying power. M is equal to, already we discussed for the telescope, what is the equation of magnification or the magnifying power? The ratio of focal length of objective to the focal length of the eyepiece. Focal length of objective is 144 divided by 6. That means the 24 is the magnifying power. Is the magnifying power of a telescope. And second, the distance between objective and eyepiece is equal to FO plus FE. FO 144 plus 6. That means the 150 centimeter. That is also known as the optical length. Optical length of a telescope. B. So this step of the numerical we can complete. Okay. And this numerical is important for the objective question 1-1. After that, the next example number 9.40. In a giant telescope, the focal length of an objective is 15 centimeter and focal length of eyepiece is given the 1 centimeter. Now, focal length of objective is given the 15 meter, FO, 15 meter, and focal length of an eyepiece is given as the 1 centimeter. What is the magnifying power or the magnification of this telescope? First, we have to calculate magnification or the magnifying power. Magnifying power M is equal to FO upon FE. FO upon FE. FO 15 meter upon 1 centimeter. Convert the meter into centimeter. So 1500 upon 1. So 1500 times, that is the magnification of this giant telescope. Now, second part, this telescope is used to obtain the image of the moon. Image of a moon. Now, the diameter of the moon is given. Diameter of the moon is given as the 3.8 into 10 is to 8 meter. 3.8 into 10 is to 8 meter. And the lunar radius of the moon is, just wait, that is the 3.48 into 10 is to 6 diameter is equal to 3.46 into 10 is to 6 meter, and radius of a moon lunar radius of a moon about this telescope or the earth is given as the 3.8 into 10 is to 8 meter. Now we have to find out the diameter of the image of the moon. What is the diameter of the image of the moon? Diameter of an image of the moon. We have to find out. There is the D, there is the D dash, we have to calculate. Now, how we can calculate it? For that purpose, just we do the ray diagram. For this, there is an objective. Here the moon. Now the diameter of the moon is this, there is the capital D. There is the capital D. Now, the orbital radius is this. Orbital radius is this. Therefore, the diameter of a moon subtended angle is alpha. And there is the radius r. So diameter d is act as an arc. And the image of this moon is formed on other side of a lens like this. At the principal focus, there is the image of the moon. There is focus at f4 distance from the focal point of a objective, and there is the diameter of the image, d dash. Again, this angle is same. There is the alpha angle. Okay, now from figure, the moon subtend an angle alpha. Therefore, from definition of angle, alpha is equal to arc upon radius. Arc is diameter of moon upon lunar radius. Therefore, alpha is equal to diameter 3.48 into 10 is to 6 upon lunar radius 3.8 into 10 is to 8. There is our. Now there is equation 1. And image of a moon subtend an angle also alpha. Therefore, alpha is equal to, now diameter of an image divided by the focal length of objective. Diameter of an image upon focal length of objective. So is equal to dds upon f0. Equation 2. From equation 1 and 2, dds upon f0 is equal to 3.48 into 10 is to 6 upon 3.8 into 10 is to 8. Therefore, d dash is equal to FO. FO is our 15 meter, 1500. So 1500 into 3.48 into 10 is to 6 upon 3.8 into 10 is to 8. So that is the 13.74 centimeter approximate. That is the value. So that is the diameter of the image formed by the objective. So only we have to use here the definition of angle. Clear this? So very easy, but here the figure is required for understanding how we take it. Okay.